Hello, this is Ong-Hee Lee from National Magnetic Resonance Facility and Medicine, and today I'm going to show you one of the recent tools, which is called Versatile Assigner. And as its name refers, Versatile Assigner is a very versatile tool to assign any kind of protein and NMR experiments, both applicable for solid-state NMR, solution NMR. But this time I'm gonna just show you how that can be used for solution animal data, which what I have right now is NHSQC, CBCACONH, and HNCACB, which are pretty typical set for assigning protein backbone by solution animal. What you need to do for using this is that firstly I highly recommend using two-letter code SQ to open up sequence entry and set your sequence here, because it utilizes your sequence information to find matching subsequences from Versatile Assigner's prediction sets. So you can use text file, ASCII code text file, sequence files such as SEQ, FASTA, or just the text file, or you can just either just write down your sequence inside here as one-letter codes and then just hit OK. So what it actually does is making a sequence file named after your project file name. So if you already have your project file name, let's say protein.proj, then the sequence file will be placed in the same place named after your project file name, adding .seq. So you will have additional file called protein.proj.seq in this case. And many of my tools for automating the tedious tasks, they will look for the sequence file anytime. So anytime when you are using them, you don't really need to set your sequence file every time. You do SQ whether you want to use store sequence file. So it's better to put your sequence like this using the sequence entry SQ. Then once you are done, what you will have is not really just the experiments. So I want you to open chemical shift reference view. They can be opened up by IR. You can see here IR, and actually it seems like I already loaded it, but well, I'm just gonna reload. So the way you can see if your experiments are already loaded or not. I mean, sometimes if you just made them hidden, then maybe you can use that PV window, which is viewless, so you can just turn off and turn on. Particularly if you have a bunch of experiments opened, then it'd be better to use this tool to make some of the experiments that are not being used at the moment. Okay, so right now we only do the background assignment, so what we really need is this guy. So chemical shift reference view, the previous video that was made a few years ago was just showing the labels, but that has been improved. So as you can see here, if you move your cursor, then it interactively shows you the probability of being certain amino acid and the histogram on right panel. So for example, if your chemical shift, well, let's say this one, if you put your cursor on the matching place right here, actually this one is from HNCACB and this one is from the current residue, not the I-1. So let's say CBCACONH, the signal shows I-1's carbon. HNCACB will have both I-1 and I, right? So this one is I because you don't see that signal in here. So if you place your cursor on the exact same position like this, then you can see that what will be the highest probable one here. As you can see, like isoleucine or serine, threonine, and so on. They will interactively change like this as your cursor moves on. Okay, that's very useful. And also you can see how the chemical shifts are distributed along the y-axis. They are from the BMLB database curated by Paxi and iPine web server. So that has been validated for such a long time, so they are very reliable. And as you can see that they are not really Gaussian. So you have to be sure that the your chemical shift can be either that or that, not really following the statistical average and deviation, because they are not really the Gaussian shape. So you have to be always cautious on determining your amino acid type. Anyways, so actually versatile assigner utilize this information. So you can open a versatile assigner by type VA. So basically what it does is predict the amino acid type based on your current selection. So let's say if I select this guy, NHSQC here, and then click predict, then this one is very likely to be histidine, threonine, tyrosine, and so on. So as you can imagine that there are 20 kinds of amino acids, so you have to be always doubt about the prediction which are over 5%. So prediction probability higher than 5% means it's leaning towards a little bit edge over the other guys, because if you divide 100% by 20 kinds, then it's going to be 5%. So if that is higher than that, then it's likely. Okay. And also if you select more peaks, then the prediction will be biased a little more towards the more likely one using the other chemical shifts. Let's say if you are selecting so let's say this one is centered, and the corresponding peaks on y-axis of the 3D experiments is actually anchored from this guy. So if you want to predict the amino acid type of this guy, then you should select the peaks that does not appear in CBCA-CONH, which appears in HNCACV. Okay. I think actually carbon alpha is actually overlapped, right? Because you don't see other peak, and then if you see closely, the peak is a little bit elongated. So I'm gonna select one here, and then that one, this one here, because this one does not appear in CBCA-CONH. That means the amino acid, the residue number for this one and this selected peak are all same with this guy. So this, let's say this one, and that one, they are residue number I. Then you can imagine that this one and this one is from I-1. So I'm gonna predict this guy. If I click predict here, then you can see that there are 4 choices. They are 4 top candidates which are higher than 5% probability. So maybe this peak would be highly likely one of them, right? But still you don't know what they are. So if you click one of them, then it will show you that particular amino acid type that you selected in your sequence information. So if your sequence contains multiple amino acid particular type of your selection, so let's say this one, glutamine, you can see that there are 6 kinds. Then you don't have any assignment for this one yet. If you click glutamate, then you see 6 kinds and so on. There is only 1 histidine and 4 arginine. But we don't know. There are, let's say, 6, 6, 1, and 4. So that means so 17 choices if we just use 5% as cutoff. So there are 17 choices, but you still don't know what that is. So actually what you can do with this first type of assigner is connecting your predictions. So what you can do is that when you select I-1 peak, I-1 peaks from CBCH-UNH, so if you want to predict I-1 in solution NMR with CBCH-UNH, you will not use nitrogen and hydrogen attached to it. And then if you click predict, there are 4 choices, and then lysine is over 50%, which is quite high. And then glutamate, valine, and arginine, right? So in this case, if you want to use predictions between the continuous residues, then you can click, okay, I'm gonna append prediction probably over higher than 5%. If you click this append 5% here, then in this history I-1 section, it will have all the probable residue in here. So residues are, so we have lysine and glutamate, valine, arginine, and they are all in here. So all the probable residues with sequence ID will be placed in here. And then this time you can do the prediction for the ith residue, the current residue. Then by that way, if you click this one, then you can see the what would be the possible for 2 continuous dipeptides. If you click the next guy, you see the other one. Actually, this one is eliminated. Histidine is eliminated, and then arginine, there is no possible ones. And actually we can set the direction, so we predicted I-1 first and then the next one. So if you click this guy, they will change like this. So you can limit the prediction. So let's say we will just do the forward walking. So we will predict I-1 and then the next guy and then maybe the next guy. So if we predict the following residues one by one, then we can just set it to the forward and then let this versatile assigner shows the only option that is continuous following the previous predictions. So then we will have less choices like that. You remember that there were at least 3 or more predictions for lysine, and then next to glutamine, then there is only 1 prediction left. Then if we click the next guy, there are still 3, and then next one, nothing, nothing. So maybe we can choose one of them. So we will have 1 here, and then 1, 2, 3. So that goes 4 choices. So it's a dramatic change. If you remember that there were like 17 probable choices for this guy, right? So we only have 4 candidates, and then maybe the assignment could be one of them here. But we already maybe almost know what that is, because if you look at here, previous, I mean for enlist the previous residue of this guy, except this valine, only remaining amino acid type is lysine, right? So lysine 33, 63, very small probability for valine for this guy, but I mean lysine is very likely at this moment for the previous residue. And then next one, we are not sure whether this residue is glutamine or glutamate, but actually you can see that there are more histories. So that means actually you can push down and then append these guys, and then you can predict the next one. So to do so, actually you want to use tree plot. So let's set up the tree plot. So open up the tree plot by type SP and then select CBCACONH, HNCACB. So I improved the tree plot quite a bit. So in most cases, the axis orders will be automatically set up correctly. So, but sometimes you have to change it. We want to have proton for x-axis, y-axis carbon, and then the z-axis will be like nitrogen. So make sure that you're looking your XYZ axis like this, HCN order. So and also the selection order is important as well. So if you select HNCACB first and then next CBCACONH, then you will see HNCACB left, CBCACONH right. So we want to select CBCACONH first and then next HNCACB. Apply and OK. So select this one and then click this plus peak. Then strip will be loaded like this. Actually, the satellites. So I'm gonna delete this. So let's make some continuous matching strips. So the next following residue can be found using strip plot. So hold shift key and then click this guy, and then this strip. And you can click SM or type SM or click this button. Try to find. If selecting two at the time that does not work, you can select only one and then do the same thing. Maybe it will be a little off due to small tolerance, so you can change the tolerance here. So carbon could be a little bit bigger than that, so I would use 0.3. So we can delete and try again if that works again. So this, yep. Then you can see that their peaks, they are from basically I think very close, or I don't know. These are pretty weak, but this is more robust, and you can see that they are side by side, right? So we want to see the NHSQC and the correct position. So there is a tool. If you go to extensions, there is a center view setup. If you go to view center view setup, or just type CV, and then actually you can set up your NHSQC, and then can see that two additional commands will be active. CP will center to center the NHSQC according to your current selection. So CP, capital C, capital P. Okay, so I'm just gonna apply, and let's go select this one and then type capital C, capital P. It's weird, nothing here. What happens if we select this guy? You can see that this one is more robust. That one is like a reach or satellite or something. So that means we can just disregard this, right? this one is very robust, while this one is much weaker in 3D as well, and then HSQC we don't even see those. So I'm just gonna delete this, right? And then delete this strip as well, not to be confused. So select one of them and then click this peak. We have duplicate strips, so we don't need this anymore. So these two strips are from the next residue. So actually wanna make sure this matches with this one more correctly because of overlap issue here. Wanna make it, I think this is fair enough. Well, I mean, if you look at this pattern here, this is satellite as well. So this one, serine or threonine, right? So we already pushed it, the predicted prediction sets to I-2 and I-1. So we just select this one is satellite, to select this one and this one, then predict. Then yeah, it must be serine or threonine. And isolation can be just disregarded because you see this carbon beta at the lower field. So when we selected these two peaks and then predicted, serine or threonine are only considerable predictions, and I'm pretty sure it's serine because threonine will have the carbon beta much lower while carbon alpha is larger than that, so it will be around here, both peaks. So serine, yeah, you can confirm using this chemical shift reference view, right? And it's more likely if you look at the carbon beta, it's more likely serine than threonine. So if you click serine here, so it will consider the serine prediction and then your predicted amino acid types, and then browse the sequence information. Then it will tell you, okay, this residue is actually this one is serine, and then not just serine, it's serine 65. So we already know that that will be serine, and then not just serine is gonna be serine 65. So what we can do is that select these two and this guy. Then if you just double click on the serine 65, you can see that it automatically assigns carbon alpha and beta, and then here has QC peak as well. And also you already know this residue, so let's move to that one by type capital C and capital P again. Then select the current residue for this NHSQC peak. So these three peaks are the ones, and we already know it's glutamate 64, while the prediction was from the previous round, which was the serine 65. So we will predict again to get our glutamate, and then if you click this one, we already know it's 64, so you can just double click on it and you can see it's assigned to glutamate 64, right? And we all know that this one is 63, right? So we just turn N and H off and predict, and it's license 63. We already know that, so we can just double click on it. So assigned to glutamate 64 NHSQC, attached I-1, which is 63 lysine, carbon alpha and beta, like this, right? So actually you can assign using assignment window AT, and then you can just choose what that is. Like this, but there is an easy way. The way you can do it is just set up your gassing. So HNCACB will provide I or I-1 for carbon, and nitrogen proton will be I. And also likewise you can set CbCH2NH to I-1 for carbon and nitrogen for I and proton for I. Once you set this, when you select a peak which has the already known resonances, it will be seen like here in gases. So there is only one choice for this, and if you select this one, this is correct one from the I-1, which is license 63, right? So there is actually another way of doing it, easier way. So you just change your cursor mode to assignment gas, then you can just actually drag over. If you have no other choices, it will automatically label the possible assignment from the gases. While we already know that it's gonna be 63, 64, 65, and then if we just find out the next strip, and then it's gonna be 66, right? So you can find matching strip. Nothing could be seen. I wonder if that is proline or something else. So you can open up the dummy graph, and yeah, next one is 366. So maybe this carbon beta is quite, you know, unique chemical shift. So maybe we can just select this carbon beta and then select this strip and find the matching strip. Voila, you can see that there's only one matching strip. So you can select this guy, click this pick button, and yeah, here is a new threonine, but maybe the peak is a little bit off the center because serine is usually around, serine carbon beta is usually around carbon alpha, so they just influence a little bit, so chemical shift could be a little bit shifted. So you know that this one is threonine 66 and this one is threonine 66 because you see that carbon beta reference here. It's definitely threonine, and then we already knew that from our sequence information the following residue is threonine 66. So we can select this guy and then type capital C, capital P to center the associated NHS fuse peak. So this one is the one, and then we select this one and this one, and from the versatile assigner we're gonna use NNH and then predict. You can see that threonine is over 92%, and then we already know the residue ID, the number will be 66, so we can just double click on it, right? So while I already have a previous residue assignment, we can just drag over while we are within the assignment gas mode. We can just tap it like this and this, so you get the assignment. So we just get our assignment for 1, 2, 3, 4, 4 residues very easily. So this is a very practical way of getting assignment. While you cannot get the full assignment, but you know that which residues are associated with your binding or your dynamic features, or like anyways, if a few residues are very of high interest, you can selectively assign by this way. But it's not really 100% perfect because sometimes your peak could be sitting in outlier that will give you a lower probability than 5%. So you already always need to be very careful. and you need to make sure that you don't have any other choices. So I mean, you can simply just follow the next one. We already know that this one is 366, so next one will be 67. So it's going to be leucine 67. So if you look at this chemical shift reference view, leucine is also very unique. Their carbon alpha and beta are very close to each other. So you can expect from, if you have multiple matching strips, you can expect that closer carbon alpha and beta ones will be more likely one, because the residue type is leucine, right? So select threonine, alpha and beta, and then select carbon CBCH0NH, and then click this matching strip. Fortunately, we only had one. Then click this pick button to load HNCACB as well, so we don't need multiple CBCH0NH. So yeah, as we expected, this one is a reach. So this one, alpha and beta for the current residue associated with that NHSQC peak. In here, I typed capital C and P to center the peak in NHSQC. You can see that they are very close, like we already expected. The following residues, carbon alpha and beta, will be close because they are leucine. So our guess was right. So we can predict using versatile assigner. Yeah, leucine is almost 70%. And then if we select this guy, and there is 67 leucine here, we will assign 66 and the following is 67. We can just double click on it, then it automatically puts the label like this, and like we already know that it's 66 threonine, so we can just drag over with the our assignment guess mode. You can see the cursor icon is guessing mode, which has the question mark in the box. So while you are in the guessing mode, if you don't have any other multiple choices for the selected peak, it will put label right away. So it's so much more efficient than typing everything by your hands. Okay, so if you look at this dummy graph, the next one will be histidine. So histidine is a little bit separated alpha and beta, as you can see, and let's do it and see if that our expectation also matches with this chemical shift reference view. So select carbon beta and alpha and the strip of CBCH0NH and click match. Luckily, only one. No, there are two actually. So we don't know what that is right now, but I mean, we already know that the next residue, which is histidine, will be separated alpha and beta chemical shift for carbons. So we can load HNCACB one by one and determine which one is correct one. So let's load a strip associated with this selected peak. We don't need to have two CBCH0NH strip, and we can do it again for this one. We can make this one. So carbon alpha and beta for the current residue associated with HNCACB is this one and this one, because they don't appear in the CBCH0NH, right? And we want them to be separate enough to be histidine, right? And as you can see, this guy, that guy, and then if you see the distance between carbon alpha and beta, they are all separated. Then we need to compare the individual chemical shift positions. If you look at carbon alpha position, put your cursor on here, and the chemical shift reference view, it's in the range of histidine. So this range is one standard deviation from the BMRB. So it will be a little bit, you have to consider a little bit more generous, but I mean, if that is inside, that's very nice. And this one is outside. And if we put our cursor on beta here, this one is within the range. This one is also outside. So I would say this one is more like 1 according to the statistics. So what I would do is assign this one as histidine 68 and then bring up the next matching strip to see if that is more like a leucine 69, right? So I will remove this 2 first and then bring next strip. Select this one and then delete the erroneously picked peaks. I don't think this one is actually the leucine carbon alpha. I think overlapped in here. Right. Yes, you can see that this peak position is here and then this one is vertically elongated. So it's overlap. I'm gonna place a peak right here and then to make it the intensity equally distributed to make shape like this. I think this peak should be around here, and I don't think this one is correct one, so I'm just gonna delete this. And then if you place your cursor on here, it's leucine, right? Leucine. So we expected leucine 69, and I'm pretty sure that it's leucine 69. This is correct. Histidine 68. So we can just choose this one and type CP to center NHSQC, and just gonna select this one and that one and that one, and leucine 69 can be assigned by a versatile assigner. Oh no, this is not leucine. So histidine 68, right? Easily assigned, and this one, that one, is leucine 69. Right? And then you can fill the missing gaps by using the assignment guess option like this. It's pretty fast. So you can do similar thing for side chains. Like if you have CCONH and HCCONH, and solid state NMR data could be assigned similar way. If you have NCOCX and NCHX or CANCOCX, if you can lay in sequential order, then you can use this versatile assigner to assign amino acid types, and then you can connect the predictions to determine your subsequence using your sequence information and your predictions. Thank you for watching, and if you have any further questions, please leave comments.